Hey everyone, in this tutorial we will learn how to use SWR, which is a React library for client-side data fetching. SWR was created by Vercel, the same company that also created NextJS. So normally when we do client-side data fetching in a React app we use useEffects and useStates, right? But SWR has a lot of benefits over normal client-side data fetching with useEffect. For one, SWR caches the data that we are loading client-side. So if we open the same page again after navigating away, or if we load the same data in different places in our app, then SWR will automatically load the old cache data first, show it immediately on the screen so we don't have to wait for a loading spinner to finish, and then in the background it will go ahead and fetch the latest updates and refresh the screen if necessary. SWR also makes it easier to share data in different places in our app because we don't have to pass the state between many different components. We can avoid this whole prop trailing problem, but you will see how this works in this tutorial. But SWR also has a ton of other very useful features besides caching. For example, when we fetch some data but there is an error on the server, then by default SWR will go ahead and try refetching this data in a certain time interval. It also deduplicates requests to the same endpoint that we do in different places in our app. So if we have a detail screen and we fetched some data there, but we also have a list screen where we fetch the same data, then we don't unnecessarily make the same request twice because SWR automatically recognizes that this is the same request and it deduplicates the request by fetching it only once and sharing the data in these different places. And this all just works without having to configure a lot of stuff. It also takes care that we don't have race conditions, which can very easily happen in useEffect. We will see many of these different features in action in this tutorial, but first let's take a look at the app we will be building here. So as said, we will build a little Pokedex app, and every Pokemon you can see here on the screen is fetched via SWR. So this app is built with NextJS, but we don't do any server-side rendering in this tutorial. We only focus on client-side rendering. If you want to learn about server-side rendering in NextJS, I have a NextJS crash course here on YouTube that you can watch. I will put a link to it into the info card box in the top right corner of this video. But here we only use SWR. So again, all of these Pokemons are fetched client-side, which we can make more obvious by just refreshing the page, so we can see the progress bars again. And normally this would load faster, but I put an artificial delay in there, just so that we can see it loading for a few seconds, because otherwise this would load almost instantly. Okay, so this is the first page of results. If I load the next page, then we see some loading indicators again, and we load all Pokemon of the second page. Until now this is nothing special, but we can see the caching in action when we now go back to the previous page, because even though this is a different URL, the data is there instantly because this is the cached data. Now nothing about the actual data of these Pokemon on the server changes, but if there would be a change, we would see the update after a short moment, because first SWR shows the cached data, but in the background it also goes ahead and fetches the data again, and if there are changes it updates the data in the cache. We can see this by taking a look in the network tab, where we can see all the network requests. So let's open the second page again, which again is cached. So we see the data instantly, but we can also see that we go ahead and make fetch requests for all our Pokemon here and return the latest data. Now when I click the details page of a Pokemon, we see a larger image and some more information. But again, even though this is a different page on a different URL, we saw the data instantly. There was no loading indicator, because this is pulling the Pokemon information from the same cache. If I open one of these Pokemon but I refresh the page, and when we refresh the page the cache will be cleared by default, then we see a loading indicator again. Because now this Pokemon isn't in the cache anymore and it has to be loaded from scratch. We can see it a bit more obviously by now navigating back, because when I navigate back to the Pokemon list, you will see that the entry for Eradicate will be there instantly, because again this is coming from the cache. But since we refreshed the page and cleared the cache, the other Pokemon are not in the cache anymore, so they have to be loaded. So now when I navigate back, just pay attention that Eradicate is the first result we see. And there it was. And the other ones still have to load. But now again they are in the cache, and we can view their data on different pages by just pulling from the same cache. We will also learn about mutations in this tutorial. Mutation just means that we update some data on our server and then we want to update the local cache in response to it, right? So for example, we can type in a nickname for this Pokemon, like Ferdinand, and when we send this nickname, it will update the name of the Pokemon on the server. It will get the updated Pokemon as a response back from the server, and we use this response to update the local cache. Now here I'm actually faking this because this is not my server where these Pokemon are coming from. This is a public API. So instead of making an actual post request to the server, I just fake this, but we still update the local cache. So I click set nickname. It changes the name of the Pokemon to Ferdinand. But since the data on the server is still the same as before, if I put a focus on another window, just by clicking on another window on my computer, and then click this tab here again, SWR notices that we refocused this browser window, which will by default trigger a revalidation. So it will fetch the data for this Pokemon again, just so that we can see the latest data on the screen. Of course, this can all be configured, but this is the default behavior. This means that when I now click on this window, after a short moment, you will see that the name is changed to Raichu again. Let's try it out. I click, short loading time, and then it's back to Raichu. Why? Because this is the data that is actually stored on the server and we just revalidated this whole screen. Alright, so this is the project we will be building here. I think it's a fun way to learn about SWR. We also built this whole thing in TypeScript. I don't use JavaScript for any of my projects. But of course, this is not a beginner course. You need experience with React to understand this. I have a full MERN beginner course here on YouTube where you learn the basics of React. You can find this video in the top left corner here, I will link it. Again, I also have a NextJS crash course here on YouTube, which is linked there as well, where we learn about server-side rendering and so on. And then lastly, I want to mention that I also have a more advanced NextJS course, which is paid, but it's huge. I still have a few videos to finish, but the course is already almost 20 hours long and we built a big NextJS app with an Express backend, with TypeScript, with tons of features. It's an amazing course, I'm very proud of it, we learn a ton of stuff there. If you want to check this one out, then you can go to codingandflow.com/nextjs. This will bring you straight to the course. Alright, and then I wish you a lot of fun with this SWR tutorial. Okay, so as usual, the easiest way to create a new Next.js app is to use this create next app command here, which we can find in the Next.js documentation. You can also just type this out by hand. And in order to execute this, we need Node.js installed. But if you have built a React app before, then you probably have this installed already. Otherwise, go ahead and install it from nodejs.org. Alright, and then we want to create this next app somewhere on our computer. Gonna put it here. Open the command line. On Windows, you shift and right click and then click on open PowerShell window here or open command window here. Yeah, which opens the command window. I don't know how to open the command line in Mac and Linux, but you probably know how to do this. If not, then just do a quick Google search. Okay, and here we want to insert this npx create next app at latest command. Press enter to execute this. Enter Y to proceed. And then we do some configuration. What is your project named? I'm gonna call it NextJS Pokedex. Would you like to use TypeScript with this project? Yes, absolutely. ESLint as well. We don't need Tailwind CSS here. The src directory is personal preference. It just puts all the source code into another folder. I usually use this, so I select yes. We don't want to use the experimental app directory. We are using the pages directory here. So when it asks you about the app directory, please select no. What import alias, we keep the default here. And then it creates this new Next.js project. Alright, and after this has finished, we can close the command line. And it looks like I accidentally put this into the already existing folder. Here's the Next.js Pokedex app we just created. But I want to have it here in this folder. Okay, and then we can open this project in VS Code. Either right click open with code. If you don't have this option, then you can just open VS Code or your favorite IDE, open the project there. And then we get a new Next.js project with a lot of boilerplate and configuration already set up. So we have a package.json, for example, with some default dependencies we need. We have a tsconfig file for TypeScript configuration. We have a default page already set up, and so on. And next we want to install a few more dependencies that we need here. So we open the command line. I do this with Ctrl Ö. You probably don't have an Ö letter on your keyboard. You can click up here on terminal and on new terminal. We open this, make this a bit smaller, and then we type in npmi for install. We need Axios. We need Bootstrap. I use Bootstrap because it makes it very easy to quickly set up a UI with buttons and everything. We need React Bootstrap and make sure that the spelling is correct, so it recognizes the correct packages. And lastly, we need SWR, which is the thing we actually care about in this tutorial. So we install all of those, which adds them all as entries to the package.json. Axios, Bootstrap, and so on. They are all in here now. Now, if you watch this tutorial in the future, then the version numbers you have might be different because they are updates. Sometimes these updates break things and suddenly stuff that worked before works differently now. If you run into any problems, you can also install the exact same versions I'm using here. For example, I'm using SWR 2.1.3, right? In the future, if SWR was updated but you want to install the same version, then you can type in npmi SWR add and then the version number 2.1.3. This will install this dependency with this version, and then you shouldn't have any problems following this tutorial. Now when we open the command line again, we can execute npm run dev to start this app. Run dev is configured here in the scripts block and it executes next dev under the hood. And this starts this Next.js app in development mode on localhost 3000. So now you can just open your browser window on localhost 3000 and you will see this default project here with some placeholder layout. I'm gonna put this into a split screen so that we can see the code and the layout at the same time. The first thing I want to do is I want to get rid of some of the boilerplate code that is set up here. So in the global CSS file, where we can insert global CSS that will be applied throughout the whole app, we have a lot of stuff in here that we actually don't need. This just comes with a new Next.js project. First of all, I want to make the whole root block here empty. Then we can delete this whole media block below. We don't need any of this stuff. We keep the block with the star here as it is. From HTML and body, we remove overflow x hidden. But I want to set in min height to 100 VH, which stands for viewport width. This just makes it so that our background color later is drawn properly, because in the body block I want to change the background color to a cool looking gradient. So here I just copy paste something. You can pause the video if you want and type this out by hand. I will also put a link to the repository of this project in the video description below where you can copy paste this from. But this is just styling, so you can also skip this or just use this normal background color here. Because this color is a gradient which just looks cooler, and this is basically a fallback, a single color. Alright, pause the video and type this out if you want. Then I'm gonna continue setting this up. From the link block we remove text decoration none and then this last media block. And that's it for the changes in our CSS file. Now when we save this, the page looks a bit different, but we will get rid of this front page here anyway. But you can already see the gradient that I set up. I just think it looks cool. It goes from this light color to a darker blue. But again, this is just styling and you don't have to use this. But I just realized that I removed the wrong value here from this A block, from the link block. I want to remove color inherit and keep text decoration none. And now our global CSS file is all set up. Then we open the sidebar again and we wanna delete this whole home module.css. This is a CSS module that's used to style the front page here, the home page, but we don't need this at all, so let's just delete it. This shows an error because this home module CSS was used in the index.tsx file, which is the home page. Again, if you want to learn more about CSS modules or how routing in Next.js works, you can watch my Next.js crash course here on YouTube. But here I will not explain some of the stuff because we want to focus on SWR in this tutorial. So here we remove this whole main block, all of this stuff, because this is just an example project here. We don't need any of this. We delete this and instead we put a div in here with an h1 headline that will say gotta cache all. That's just a funny wordplay I came up with, because this is not gotta catch them all, it's gotta cache them all, you know, because we are caching data. In front of the M I want to put an apostrophe, but in HTML code we have to escape this with ampersand sign, apos, semicolon. And now this renders an apostrophe. Then we have this font here and this head tag. Again, I explained this in my NextJS course. We want to move this stuff over to the _app.tsx file, which is the component that wraps our whole application. So here we can do a global configuration basically. I want to apply a font to all our pages throughout our app. So I move this here. Also the import statement, the inter one, which is a Google font, by the way. This is a new NextJS feature with which we can easily host Google fonts on our own server. So this comes with NextJS by default. From here we can select between different Google fonts. I actually want to use a different one called Anton. So we replace this here and here as well, and then we call this const variable Anton. This Anton font requires us to set a font weight in here in the configuration. So after subsets we pass weight, colon, then we pass an array with one string inside, 400. This is the font weight we are loading here. In order to apply this font to our whole app, we want to wrap this component here into another div. So first of all, I wrap this into parentheses, so I can put this into a new line as one expression. Then I want to wrap this component, which is responsible for rendering the page itself, so all our pages throughout our Next.js app. I want to wrap this into another div, so I cut out the closing tag, put it down here. And now on this div we add a class name, and between curly braces we write Anton, which is this variable up here, dot class name. And when we save this, this should apply this font to our whole app. Sometimes this doesn't work immediately. Okay, I haven't restarted the server. So again, we open the command line, npm run dev. Then we refresh the page. It should be loaded again. And now we have the correct font. This is Anton. Now I will zoom in a little bit so everything is visible properly. Then we also want to wrap this component into a main tag, which is just an HTML tag that says, okay, this is the main content of the page, excluding any navbars or photos or anything that's the same between many different pages. This doesn't matter for this tutorial at all, but I think it's good to do it properly. And then I want to wrap this into yet another tag, into a container, which is coming from React Bootstrap. So it should add this import statement here. We close this and again put a closing tag below the component. And the container just adds some margin to the sides of the content, so the sides of our page component here. But it's not applied yet because we haven't added the Bootstrap CSS yet. So on the React Bootstrap page, on the setup instructions, somewhere here is the CSS. Again, you can just type this out by hand if you want. And we want to add this in the app.tsx file, but above our global CSS line. It's important that we put it above because this way our global CSS overrides anything we change in the Bootstrap CSS, because CSS is applied in the order you imported here. So the one below will be imported later and it will override the CSS above it. Okay, so when we save this again, the Bootstrap CSS should be applied, which should add some padding to the container. And there it is. It's not big, but it makes a difference so that we don't have our text at the edges of the screen. But I also want to add some padding to the top and the bottom of the page, so I go into the container opening tag and add a class name here. And then I enter this py-4 class, which is a Bootstrap utility class that adds some padding to the top and the bottom of this container. Now when we save this, our page content has a bit more room. Okay, then I also want to move this head tag here over to the app.tsx file. So I cut it out from the index.tsx. Then here at the beginning of the return block, I add an empty fragment. I put the head inside here and the rest of the layout right below inside the fragment. So now we have these empty tags here, which is a React fragment, and this allows us to put multiple tags here inside it. Then we have to import head from next head. This should add this import statement here. And the next head contains metadata about the page, like the title that we can see in the browser tab up here, or the description, which for example is shown when we post a link to our website on social media. Again, I explain all of this in a bit more detail in my NextJS courses. But now let's clean up our index.tsx file, so we don't need this fragment here anymore because we don't have a head tag in this component. I also want to center the h1 on the screen, which again we can do with some Bootstrap utility classes, text center, and mb4, which adds some margin bottom to the rest of the page. So now this is centered on the screen. Then let's remove these unnecessary import statements, and that's it for the index.tsx file for this part. I can actually close this. I want to change the title of the app to, I don't know, NextJS Pokedex, for example. When we save this, it changes the text here in the tab title in Chrome. And since we put this into the app.tsx file, this title is applied on all our pages. And you can override it by adding a head tag to a specific pages with a different title. Again, we do this in my NextJS course. And I want to change the description right here to NextJS Pokedex app by coding and flow. We can't see this in the browser, but again, this would be visible, for example, when we post a link to this website on Twitter or Facebook. Okay, that's it for the setup of our app.tsx file. And we want to fetch the Pokemon data from this PokeApi.co website, which is free to use. You can take a look at the documentation if you want. We want to fetch data for a single Pokemon, which we can do via this URL structure. And we also want to fetch lists of Pokemon for our overview page. And this list can be paginated, so we can only fetch a certain number of results and then load the next page when we click the next page button. So now what we do is we go back into our code and create interfaces for these different JSON responses so that we can work with this data in our app, right? But we don't need all the data that we get back. We will ignore a lot of these fields. We only really care about the name of the Pokemon, which is here. And then we will also load some metadata that we can show on the screen. For example, the types or the height or the weight of the Pokemon. But you can load different data if you want. This is totally up to you. And the picture of the Pokemon is contained here in sprites. Then we have other, official artwork, front default. This is also something that we want to load so that we can show an image of the Pokemon on the screen. So let's go back into our code, open the sidebar, go into SRZ, and inside SRZ we create a new folder called models. And in there we create a new file called pokemon.ts. Now in normal JavaScript you don't have to do this because there you don't really have types. You can just add any field anywhere willy-nilly. But in TypeScript we have to tell the compiler in advance what kind of data we want to work with. So what we do is we export an interface here called Pokemon. This will contain the data for one Pokemon we return from the API. So this data here, but just the fields we actually care about. So we want the name, which is of type string. And the name has to exactly match what we get here in the JSON. So somewhere here is the name field. So you have to make sure that the spelling of the fields you want to get is the same as here in the JSON response. Then we want to get the types. But for the types we have this nested structure. Let's see where the types are. Down there, it's an array of objects And each of these objects contains this type field here, and in there is a name. This is the actual value we care about. So we rebuild the structure here in our interface. So this is an array of objects, right? So we add curly braces and then square brackets behind it. And between the curly braces, we put the structure of these single type objects. You could also create separate interfaces for them, but since we don't want to reuse these types anywhere, I just write it directly in here. So in this object, there is this type field, remember, which is another object that contains the name of the type, which eventually is a string. And then we get a whole array of these types. We also want the weight and the height, which are both numbers. And again, this is contained in the JSON response. And then the image of the Pokemon, which again is inside sprites, which is an object, which contains other, which is also an object, which then contains a field called official minus artwork. And since there is a hyphen in between, we have to write this between quotes. Otherwise, we can't use a hyphen in here. So again, this is the name of the key, which is yet another object. And in here we have front underscore default. For underscores, we don't need the quotation marks, which is a string. And this is the actual link to the image we care about. But again, this whole structure is dictated by the JSON we get back from the API. So we have to follow the same structure. And then we also want to create an interface for these paginated results we get back. So above or below doesn't matter. I export another interface called Pokemon page. And a Pokemon page actually doesn't contain all the data of a Pokemon like we have it here. Instead, it only contains the name of the Pokemon and the URL to the details of the Pokemon, where we then get more information. So this is the same data as we would get from this Pokemon endpoint. Okay, so in our interface, we want to have this next value here, which points us to the next page, or null if there is no next page, and previous, and then the results are contained in an array. So back into our code. So we add the results key first, which is an array of objects, and each of these objects contains the name field of the Pokemon in form of a string. Then we have the next link, which is a string or null if there is no next page, and the same for the previous page. Okay, and that's it for the models here. We don't need any other data. Again, if you want to show more data in your Pokedex app, then just add them to the Pokemon interface and take a look into the documentation for all the data you can fetch. Just one more thing, looks like I forgot a comma here. So we put it there. To fetch this data from the API, we will use Axios, which is a fetching library that is much better than the native fetch function we have available in JavaScript. But we have to add some little configuration for Axios. So in the SRC folder, we create another folder called network. And in here I put a file called Axios instance.ts. In this file, I want to import Axios from Axios. This is a dependency we added earlier to the package JSON. And then we can set up a reusable Axios instance. So I create a const Axios instance, the same name as the file name. Doesn't matter, but this is just personal preference. And we assign this to axios.create. Parentheses, curly braces, because in here we can do some configuration, which will then be used with all API calls that we make through this Axios instance. So a cool thing we can do is we can set a base URL here so that we don't have to repeat it for every separate API call we make. And we get the base URL from the documentation. This part here is the part of the URL that never changes. So we use this as the base URL by passing it as a string. Then we can configure this a little bit. For example, we can set a timeout of 5 seconds so that a request will be aborted if it takes longer than 5 seconds, but you don't have to add this. There's more configuration we can do in Axios, but this is enough for our use case. And then we want to export default this Axios instance so that we can use it in other files. Then before we can actually put something on the screen, there's one more file we have to prepare. This is the file that will actually contain the different API requests to the different endpoints here. And this file will use our Axios instance. So again, we open the sidebar and add a new file to the network folder called Pokemon API.ts. In here, we want to import our Axios instance. And I'm gonna call this API. Since Axios instance is the default export here, we can give it any name we want when we import it. You can call it Axios instance, but I want to call it API. And we import this from ./Axios instance, which now points to this file here, Axios instance.ts, and to the default export. Then we create two functions for the two API requests we want to make. We want to make requests to the Pokemon endpoint to get the details about the Pokemon and to this paginated endpoint here. So, in the Pokemon API file, we export an async function, async because we are making a network request which takes some time, and we call this getPokemon. And we will have to pass the name of the Pokemon we want to load as a string to this function. And I prefer to have my API calls inside these API files, so we have these nice clean functions that we can call instead of putting URLs directly into our components. But again, this is personal preference. Okay, so the URL of the endpoint we want to make this request on is /Pokemon/ and then the name of the Pokemon. So in here we create a const response for the data we get back equals await. Then we take our Axios instance, which we called API, .get because we are making a GET request with Axios here. And then we can add a type argument between angle brackets with the type of data we get back from this API, which is one of our Pokemon objects, right? Which we import from the models folder. So we add this as a type argument between angle brackets. And then parentheses where we enter the actual URL endpoint we want to make this request on. So we insert a string to /Pokemon/ and then outside of the string we append the name of the Pokemon we pass to this function. And we don't have to repeat the base URL again because this is already set up in the Axios instance. So this part here will be appended to the base URL. Alright, and then we want to return response.data from this function, which will be of type Pokemon, because this is what we used as the type argument here. And then we need one more function for fetching a page of Pokemon. So again, export async function, get Pokemon page, and we will pass the page number as an argument to this function. Here let's set up a page size in a variable. I'm gonna set this to 12, so we will load 12 Pokemon per page. And then we make the actual request. Again, const response equals await API.get. This time we expect a Pokemon page back as the data. And for the endpoint, again, we pass a string, but this time we use backticks so that we can put variables inside the string. We make this request to /Pokemon, and then we add a question mark to add the query params. And again, this is described here. After the query params, we can define limit, which defines how many results we want to load, and offset, where we can say how many results we want to skip to load the next page. So after the question mark, we write limit equals, then we add a variable here, which we can do in a backtick string with a $sign and curly braces. We want to limit the results by the page size. We only want to get 12 results at once. Then after this variable, we put an ampersand sign to add another query param. We also want to set the offset to equals. And here we define how many results we want to skip. We want to skip page size times, and then between parentheses we write page -1, like this. You can pause the video and type out this exact string here. So if we pass page number 1 to this function, for example, then page -1 will be 0, meaning that we don't skip any pages and we load one full page, the first page. If we pass page number 2, then we will skip page -1, which is 1. So we skip one full page, which makes sense because we want to load the second page, right? So we want to skip one page. And this is how we paginate the results. And then again, at the end of this function, we want to return response.data, which contains the actual Pokemon page. So our setup is done. Next, we want to go ahead and actually use SWR to fetch data and cache it and all the good stuff. Okay, so first I want to set up a page where we can show the data of a single Pokemon. And I want the URL to be a localhost / and then the name of the Pokemon. So for this we create another page in the pages folder here, which we have in NextJS by default. We create a new file called in square brackets Pokemon, and this is a TSX file. I explained this URL structure in more detail in my NextJS beginner course, but this is how we can put a variable into the URL, meaning that we can put different values in there, different Pokemon names, and then we can get this Pokemon name out of the URL inside a component. So in this file we export a default function. So we export a JSX component called Pokemon details page, but this name is up to you. Only the name of the file here is important. The name of the component itself doesn't matter. Parentheses, curly braces, and in here we put a return block. Like this. So first of all, we want to get this Pokemon value out of the URL. To do this client side, we have to use the next router. So we create a const router and call this useRouterHook from NextJS, which will add this import statement up here. From this router we can get this URL value here, the Pokemon name. So we create a const Pokemon name equals router.query. This is how we access these params. Then the name of the param we want to access, so the same word we put between the square brackets here, Pokemon. And by default, the type of this query params is string, string array, or undefined. We only expect a single value here, so we call toString to turn this into a normal string. This adds the save call operator because Pokemon can be undefined, which would be the case if we rename the name of this argument here in the URL, but forget to update it here. Now we expect this to have a name, but just to be sure, we add a fallback value of an empty string. So if the value of this URL param is indeed undefined, then we will just use an empty string instead. Okay, and in a normal React app, we would now go ahead and use useEffect and state to fetch the Pokemon for this name from the API and then show this data in the UI, but here we want to use SWR because it's much better than a normal fetch. First of all, we have to import SWR. So up here we write import use SWR like this from SWR, which is the name of the package. And then we also want to import our Pokemon API file here. So we write import star as Pokemon API. This way we can import these functions under this namespace from add, which is the root folder, src, add/network/ and the name of the file is Pokemon-API without the file ending. Then below the Pokemon name here, we create a const with curly braces because we want to destructure the object we get back, equals sign, and then we call use SWR, parentheses. And as the first argument, we pass the Pokemon name, comma, and then we pass Pokemon API dot get Pokemon, which is one of the API functions we set up earlier. But we don't call this function here, so we don't add another pair of parentheses. Instead, we just pass the function name, which creates a function reference. So this way we use SWR to fetch a Pokemon from our API. And SWR will automatically take care of all these cool features like revalidation, error handling, caching, deduplication. This all happens automatically, just by wrapping our API call into this use SWR function. Now the first value we add here is the key for this entry in the cache. This key is how we uniquely identify an entry in the cache. So each Pokemon name will have their own entry in the cache. where we can get its data from. And this key here is also passed to the fetcher function we passed as the second argument. So in other words, we could also write it as an arrow function like this. We could add the Pokemon name here, which is a string. And this function calls the getPokemon function and passes the Pokemon name to it. This is the exact same, just that we use the short syntax here where we pass the function reference directly. Again, this key is passed as an argument to getPokemon. GetPokemon expects a name, and that's coming from the Pokemon name here, which we get from the URL. And between the curly braces here, we can get a bunch of different values. We can use autocompletion to see which they are. Right now we only care about the data, which is the actual data we get back from the API. And this is loading value, which will be true while the data is loading, so we can show some kind of progress indicator. And all the data fetching and deduplication and so on now happens automatically. We just have to wrap this into a useSWR, so it's very easy to use. Now in the SWR documentation, they often use the URL of the endpoint as the cache key, but you don't have to use the URL. We can also use any other value like the Pokemon name, because again, I like to put these URLs into these API files rather than cluttering all my component code with them. And useSWR also makes our code more declarative, because now our component here doesn't describe how the data is fetched, which we usually do in a use effect, where we make the API call and we set state and we catch errors and then we do something in response to an error. But in React, we prefer to have declarative code, where we just say what we want to do, but not how we do it. How we do it is handled inside useSWR. It's abstracted away. Now let's also rename these values we get back, because data and isLoading are very generic names, right? We can rename these values with a colon. So let's rename data to Pokemon, because this is the actual Pokemon data we get back. And we rename isLoading to a Pokemon loading. And then let's build a layout in the return block that actually renders this page. So in here I put an empty fragment because again I want to put a next head in here from the next head import. Close this, and in here I want to overwrite the title of this page. I want to put the name of the Pokemon we fetched into the title of the tab. But the Pokemon data will be undefined until we actually get something back from the API. So while this is loading, it will still be undefined. So we have to handle this case. Inside head, we add curly braces so we can put an expression here. We want to check if Pokemon is defined. So we write Pokemon and 2 ampersand signs. So the right side of the expression will only be rendered if Pokemon is not undefined. If this is the case, we want to set the title with this title tag, which we are also using in the app.tsx file here. We want to change this value to another one. So we add another pair of curly braces here because I want to enter a backtick string. And I want to start this backtick string with Pokemon.name. That's the name of the Pokemon we loaded. And then minus NextJS Pokedex. Let's actually save this and try this out. So if I type in, for example, /Bulbasaur, then we load the data for Bulbasaur. We don't see anything on the screen yet because our layout is empty, but we see the name of the Pokemon in the title of the tab. Now the PokeApi returns all these Pokemon names in lowercase letters. I don't know why, but I don't want to change this here, so I'm just going to keep it like that. Now there's a reason I created this backtick string instead of just putting the text directly between the title tag. If we do this, Next.js actually complains because it expects one element in here. And if we put variables and strings directly into this title tag, then it's not considered one element, but it's considered one element when we add it as a string. While it's not so important that you understand this, just write out the title exactly like I did here, and it will work properly. Okay, then let's finish setting up the layout below the head tag here. We add a div, and I want to add some utility classes to this div. Just follow along. dFlex makes this a flex box. Flex column makes this a flex column, obviously. And then I want to use line minus items minus center. There's a typo in here. Has to be written like this. I think this is self-explaining. And in this div, first of all, I want to put a paragraph tag that will contain a next link. Next links are used to navigate between different pages within our NextJS app. You should use this instead of a normal A tag. We set the href of this to a string, which is just slash. In other words, this brings us back to the home page. I also want to add a class name to this link, which is link light, which just makes this link white. Then we close this tag. And in here we put the text of the link. In here I want to put such a left arrow. You can copy this from Google. Just type in left arrow character and you can copy it from there. And again, Pokedex. So this puts this link up here that brings us back to the front page. This is all I want. Then as long as the Pokemon is loading, I want to render a progress indicator. So we have this Pokemon loading value up here from useSWR. So we add another expression in curly braces. We check Pokemon loading to ampersand signs. Then we want to render a spinner from React Bootstrap. And on the spinner we want to set the animation to grow. This is described in the React Bootstrap documentation, but when we refresh the page we should see this for a short moment. But we don't. I think it's just loading too fast. So what I want to do is in the Pokemon API, I want to add an artificial delay when we load a Pokemon, just so that we can see the loading states better. So here at the start of get Pokemon, I add a const delay. And obviously you never want to do this in production. This is just for our example here. I want to assign this to math.random to get a random value. And by multiplying this with 2000, we get a random value between 0 and 2000, so between 0 and 2 seconds. Then below, since this is an async function, we can call await new promise. Just follow along. To this promise we pass an arrow function with this r argument, which is the resolve function. And here we call z timeout, parentheses, and to this we pass r, comma, and delay. So this basically creates a new promise, which waits for our delay time, so between 0 and 2 seconds before it resolves the promise. And since we are awaiting this here, this whole function will wait until this is finished. So this way we can just create an artificial delay. So let's save this and refresh the page again. And now we see the loading indicator, which takes between 0 and 2 seconds now. Okay, back into the Pokemon page. So below, we add another block of curly braces. We want to render the content in here only when Pokemon is defined. So after it has finished loading. So Pokemon to ampersand signs. And here I put another fragment because I want to put multiple elements in here, which will all be rendered under this div. So after the Pokemon has loaded, I want to put an h1 in here, which will render Pokemon.name, and I add a class name prop here as well, which will be text center, and another one after a space, text capitalize, and make sure the spelling is correct. So this now shows the name of the Pokemon, but it capitalizes the first letter with these Bootstrap utility classes here. This is what text capitalize does. And it does this by adding a CSS attribute. Okay, then below we want to put the image of the Pokemon. For this we use a next image, which we want to import from this entry here, next/image. It's important that you use the correct one, because next images are really cool. They take care of automatically resizing the image to the appropriate size. So here first we add src, which is the URL of the image we want to load. And this is contained in our Pokemon data. Inside sprites, remember this is what we added to the interface earlier. We want to get all the way here to front default. So Pokemon.sprites.other.official artwork, and again, since this is a string with a hyphen in between, we have to access it like this. This is just unfortunate naming. Then afterwards we write front default, which contains the URL to the image we want to load. Then we also add an alt attribute, which is an accessibility feature. This will be read by screen readers, for example, for blind people. So here we add an expression which will contain Pokemon colon, and then we append Pokemon.name. So screen readers know what kind of Pokemon is shown in the image. And then on the next image that we load from a URL, we have to define a width and a height. Otherwise our code here will not compile. NextJS does this to avoid layout shift. So it needs to know in advance how big the image is we want to load, so that anything we put below the image doesn't get moved further down after the image has loaded, so it has to reserve the space. This is actually quite important for SEO, search engine optimization, so NextJS enforces this with its image component. But what it also does is it automatically resizes the image, so we only load the image at the size we actually need it. Meaning that if the image of the Pokemon on the backend is, for example, very big, 1000 times 1000 pixels, and we just pass, 50 for the width and height, then NextJS will actually resize this image to 50 times 50 pixels, and we will only load it at this size, which of course makes the page much faster. And this again is very important for SEO. Now I explain the next image in more detail in my paid NextJS course if you want to check this out. But here we will use it just in a very basic way by setting the width and the height to 400 on this page. Let's save this and see if we see something. Not yet, because we still have to configure this URL where we want to load the image from. This is necessary again because we do this automatic resizing of images, which requires some processing on the backend, right? So this is work our server has to do. And in order to protect us from other people using our URLs and our resources to resize their images, we have to specify in advance from which URLs we are allowed to load and resize images on our website. We do this in the next config.js file, which was created when we used the create next app command line command. Here after React strict mode, we add this images key, which expects another object, so colon curly braces, and in here we can define remote patterns, which is an array, so colon square brackets, and then in here we put another object. Then we set protocol to HTTPS, because we want to load this image from HTTPS. And then we want to set the host name to the URL where we want to load images from. And that's just the base URL here. So rar.githubusercontent.com. Then after we have entered all of this, we save this file. And then important, we have to restart our development server, otherwise the changes in next config will not be applied. So we open the command line, press Ctrl Z and then confirm it with Y to stop the execution. And then we execute npm run dev again to restart this. And then our image should load after refreshing the page. And there it is. And again, this image is resized by NextJS to about the size that we show it on the screen. And we don't load unnecessarily large images. And then I still want to put some more meta information below the image, just to make this page look more interesting. So I put another div here with the class name, the inline block, and empty tour. So we make it inline block and add some margin to the top of this div to add some spacing to the image. And in here I just want to put a bunch of text, each of them inside their own div. In this div we put a strong text which will say types colon, and then after the strong tag space, and here we want to put some data of our Pokemon. Pokemon.types, which again is a field we added here to the interface. For each type I want to get the name out of, and then I want to iterate over them and put them all into a single string. So what we have to do is we have to map the types with the map function, where we get passed each type. So this is every element in this array here. right arrow because this is an arrow function. We want to map each element in this type array to type.type. This is this nested value in here, dot name. So we turn each entry in this types array into this name string here. This is just something we have to do because of this weird nested structure we get back, but it's not a big deal. So then we have an array of strings, and we want to join this into a single string, and then we add as a string, comma space. So this will take each element in this array, so each name, and put them into one string separated by commas. Okay, and the remaining values we put in here will not be as complicated. So below we put another div, again some strong text in here which will say height colon, and then after the strong tag we add another expression in curly braces. We want to render Pokemon.height, but this is decimeters, so it's like 10 centimeters, meaning that we have to multiply this by 10 to get the actual centimeters, and then I add cm just as a text behind it. So this just puts the height of the Pokemon in centimeters into this text. So nothing special here. Let's duplicate this for the weight. Weight colon, Pokemon weight. This time we have to divide this by 10 to get the kilograms. I don't know why they are using these weird values, but now we get the kilograms of this Pokemon on here as well. Okay, cool. So now we have this data here. Of course, when we refresh the page, the cache is cleared and we load the Pokemon from scratch. To see that caching actually works, we can go into the index.tsx file, so the front page. Later we will render our full list of Pokemons here, but for now we will just put a link to Bulbasaur here. Because this way we can navigate between the front page and Bulbasaur's detail page without clearing the cache, and then we can see that the data is actually there immediately. So here I put another next link. Again, it's important that you actually use the next link. And reset the href to /Bulbasaur. Have to make sure to spell it correctly. I also add the class name to style this link to link -light, and then the text will just say Bulbasaur again. So now we can navigate between the front page and Bulbasaur's page, and the data of Bulbasaur is always there immediately, even though we are navigating between different pages. Because this data here is pulled directly from the cache from the browser. And of course you can also open any other Pokemon, like Charizard for example. And by the way, did you know that Charizard is only 170 centimeters tall? I was actually quite disappointed when I read this. And there's actually a Google Chrome extension you can install if you want to see the cache data in Chrome. You don't need this, it's called SWR DevTools. You can install this. And then it adds a new tab to the Chrome DevTools. So when we click F12 to open the Chrome DevTools, we have this SWR tab here. Let's try refreshing the page. And there's the entry for Charizard. And in there is the cache data. Now if I would change the key of this fetcher function to something random, for example, blah, and instead hardcode Charizard into get Pokemon. So here, Charizard, and then refresh this. Then we still load the data for Charizard, but now the cache key is blah, because this is what we are using here. But this doesn't make much sense, because now every Pokemon would be stored under this blah key. Instead, we want to use the name of the Pokemon itself as the cache key, right? So here we have Charizard. Let's navigate to Bulbasaur again, which loads the entry for Bulbasaur and puts it into the cache. Now, when we take a look into the network tab here, where we can see the data that we are fetching, navigate back to the front page, and then once again to Bulbasaur, we see the data of Bulbasaur immediately, but in the background, SWR also goes ahead and does another fetch request to load the latest data and update the cache with it. Now here the data we get from the API is always the same, so we don't see any updates. If you want to see an example of these updates, then you can take a look at my NextJS course, because there we use SWR to fetch user data, like the authenticated user for example. And sometimes the user has been updated and we need to revalidate the cache with the newest data. But again, this all happens automatically with SWR. You don't have to do anything special. What you can do, however, is you can disable some of these behaviors. For this you can add another argument to useSWR. The third argument can be a JavaScript object where we can do a different configuration. For example, we can set revalidate on focus to false to disable this behavior. We can change the refresh interval, revalidate on reconnect, and so on. You can take a look at this if you want, but for most cases the default behavior is perfect. And next we will learn how we can make these useSWR calls here reusable. So we can use this hook in different places in our app without having to repeat the code here and any configuration we might be adding. And then afterwards we will learn about pagination with SWR and mutating the cache. Now before we move our useSWR call here into a reusable hook, I want to show you one problem our code has right now. So what I'm going to do is I'm going to try to open the page for a Pokemon that doesn't exist. So I add a typo in here, which loads for a short moment and then it doesn't show anything because the data is undefined. And here we get a 404 error back. Now when we wait a short moment, you can see that SWR tries to fetch the data again, and again we get the 404 error. This is because by default SWR retries fetching the data if there was an error, because there could be some kind of server error and we want to retry loading the data again later. So it does this over a certain time frame, and this time frame increases. And this is usually what we want, but not if we get a 404 error back, because if there is no Pokemon with this name, then there is no point in refetching this data. The Pokemon will not be there either way. If there is a normal server error, like the server being down for a while, then we want to do the refetching, but not for 404 errors. So one way to handle this would be to disable error retrying altogether, but again we don't want to turn it off completely. We want to have this feature for some kind of errors. Instead what we can do is we can check if the error code we get back is 404, and in this case tell SWR, okay, there is no data coming for this endpoint anymore, so we can just stop trying. And we can take care of this error handling in our custom hook as well. So now what I want to do is I want to put this stuff into a reusable React hook. So in SRC I create a new folder called hooks, and in here we put a new file called usepokemon.ts. And React hooks have to start with the word use. This is a naming convention that is also enforced by lint rules, and everything that starts with use in React uses effects and or states under the hood. This is why useSWR also starts with the word use. This is a hook. And this naming convention is just there to make it clear that whatever happens in this function uses state and effects. And since you can only use state and effects inside React components, we can also only use these hooks inside React components or inside other hooks. So inside other functions that start with the use word. So by calling this use Pokemon instead of something like get Pokemon, we can use SWR in here. If you find this confusing, you can read the documentation about custom hooks in React. But this is how this works. So here we export one default function with the same name, use Pokemon, where again we have to pass the name of the Pokemon we want to load. Let's split this tab so that we can move the code from the Pokemon page over here into our new component. So we basically want to cut out this line here, put it over here, which also means that we move the import statements for useSWR and the Pokemon API over here as well. Then instead of renaming these arguments right here, we remove this. And instead, we return an object with these same names for the fields. So Pokemon colon will contain the data, and Pokemon loading colon will contain is loading. And the color of this use Pokemon hook can then use these values. And here for the key, we change Pokemon name to just name, because this is the name of the argument. So now without changing anything else in here, we can again go into our Pokemon page, create a const, assign it to our usePokemon hook, where we now only have to pass the Pokemon name, the rest is handled internally. And out of this, we get the Pokemon and the Pokemon loading value. And now when we save this page works exactly the same as before, just that we now have a reusable hook. So let's go to Bulbasaur again. And now we can use our usePokemon hook on different pages to fetch the same kind of data, which is always pulled from the same cache and automatically deduplicated. Deduplication means that when we navigate, for example, from the Pokemon list page to a Pokemon detail page, and we load the same Pokemon in both places, we don't execute two fetch requests to the same endpoint. Instead, we only have one. But we still have this error retrying problem I was talking about. So since this Pokemon here is not found, SWR goes ahead from time to time and tries to refetch the data. Instead, we want to tell SWR, okay, if we get a 404 status code back for a Pokemon, it means the Pokemon doesn't exist, right? So we have to check for this status code we get back when an error happens. So what we can do is, instead of this function reference, we can just pass an async error function like this, which then uses the API function in its body. So here we can add a try catch block. In try, we want to do the same as we did before. We want to return await Pokemon API dot get Pokemon and pass the name of the Pokemon to it. And then return this data from this hook. This has the same effect as before, just that now we wrap this into this arrow function with a try catch block inside. But if we would save this, it would still work exactly the same as before. And again, we could also add the name argument to the arrow function because the fetcher function receives the key. But since we already have this value here from the arguments, we don't need to put it here. Okay, so and now the reason why I wrap this into try catch is that now in the catch block we can check if error is an instance of Axios error, which is the error that Axios throws if there was a failed network request. For example, our 404 response. So if this is an Axios error, and to ampersand signs, if error.response.status, which contains the status code, is equal to 404, then we don't want to keep retrying this fetch request. Instead, we just want to return null. Then we will get null for the Pokemon value, but since now we are not throwing an error anymore, SWR knows that this request succeeded just with no data because there is no Pokemon with this name. Then we add an else block because for any other kind of error than 404, we want to keep retrying. So we just throw this error here, which signals to SWR that something went wrong and it should keep retrying fetching this data. Okay, now let's save this and try this out again. So I'm still trying to fetch a Pokemon that doesn't exist. Let's open the network tab and refresh the page. So here's our failed request, 404. But now if we wait, NextJS should not execute any additional requests to this endpoint. Because now we told it, okay, the data for the Pokemon is null, you can stop retrying. This is not a normal error. And as we can see, nothing happens. But if this was any other status code than 404, then this would keep retrying. But automatic revalidation still works, unless we disable this as well. So when I click on another window, and then back on this window, we try fetching this data again. But this is not an error retry, this is revalidation, because we focus the screen again. You can deactivate this as well if you want. I showed you how you can do this in the configuration of SWR, but you can also keep this on. Okay, one more thing. I want to go to the Pokemon page once again. And I want to put another block here that checks if Pokemon is equal to null, which will only be the case after a 404 response. Because until the data is loaded, the Pokemon is undefined, but it's only null if there's actually no Pokemon. In this case, we can render some text here, which will say Pokemon not found, which we can now see here. And SWR will not go ahead and try refetching this Pokemon because it doesn't exist. Okay, and next we will implement pagination into our Pokedex overview page. And this is also where we will reuse our use Pokemon hook. Okay, so on our Pokedex overview page, we will load a bunch of Pokemons from the paginated endpoint, right? And for each entry in this list, I want to render a little card with the name of the Pokemon and the image. So let's create the layout for this card. For this, we create a new folder in SWR called Components. In here we put all kinds of React components that are not pages. And in here we put a file called PokemonEntry.tsx. But the file name is up to you. You can call this whatever you want. And in here we export default a function with the same name. To each Pokemon entry, we will pass the name of the Pokemon that we want to load. So between the parentheses here of the function, we add curly braces name to destructure the props of this component. And then, since we are using TypeScript, we have to define the type of the props. So after the closing curly brace, we add a colon and another pair of curly braces. And here again, we write name and the type of this value, which is a string. So if this syntax looks weird to you, this is the type of the props, and here we just destructure the props to get the name value out of it with these curly braces. And then to load the data of the Pokemon for this name, we can just use our use Pokemon hook, where we pass the name of the Pokemon to. And again, this is automatically synchronized and deduplicated with all other places where we use the same use Pokemon hook. Very cool stuff. And from here we get Pokemon and Pokemon loading. Okay, then in the return block, I want to wrap everything into a next link because I want these cards to be clickable to bring us to the Pokemon's detail page. So we set the href of this link to / and then we append the name of the Pokemon. This is where we want the link to bring us to. And then in here we put a div. Now I want to add some styling to the different elements, and the Bootstrap utility classes are not enough to handle all this different styling. So we create a CSS module for this Pokemon entry component. We put this into the styles folder that already exists. Right click, new file. We give it the same name as the component, Pokemon entry, but then .module.css, which turns this into a CSS module. CSS modules are really cool because they allow us to set up CSS that is only applied to a single component, so we avoid naming clashes between classes with the same name used in different places. And these CSS modules are enforced in NextJS by default. We are only allowed to write global CSS in our globals.css file, but all the CSS used inside components has to come from a CSS module. Before we set up any CSS in here, we want to import the CSS module in the Pokemon entry component. So we write import styles. Styles is just a naming convention. You can also give this a different name. From add styles / and then Pokemon entry.module.css. Then I want to apply a class to our div here with class name, curly braces, styles.entry. This is a class we will put into our CSS module like this, and it will then be applied to this component where we use it on. But before we put any styling in here, let's keep setting up the layout structure. And maybe it would be a good idea to put one of these Pokemon entry cards into our front page, index.tsx, just so that we can see the layout while we are building this. So instead of our link here, let's use a Pokemon entry, and again we hardcode the name to Bulbasaur for now, but later this will be a list of Pokemon. So right now this is still empty, so back into the Pokemon entry component. Then here again we add a block that checks for Pokemon loading, and if this is true, we want to render another Bootstrap spinner, again with the animation grow. I think we don't need a block here that checks if the Pokemon is null, because the values we will get back in these pages will not have invalid names. And also if we try to render a Pokemon entry with an invalid name, then I think it's okay to just not render anything at all. But if you want, you can put the same null block into the Pokemon entry as well. Okay, and then below we check if Pokemon is defined, then we want to render a layout again that shows the Pokemon name and the image and so on. So in here we put another div, to which again we apply a CSS module class name, styles.card. We will put this into our CSS module in a moment. Close this. In here I put an h1, which again gets the text center and text capitalize classes applied to it. And this renders the name of the Pokemon, Pokemon.name. But looks like the closing tag of the div here is still missing. So we close this and put it below the h1. And there's the name Bulbasaur. We will fix the color of the link here in a moment. But first, below our h1, we put a next image. Again, the correct import statement is important. Again, here I want to set the src to a Pokemon.sprites.other.officialartwork.frontDefault. The same image we also load on the details page. We set the same alt text again, Pokemon colon plus Pokemon.name appended to it. And this time I want to set the width and height to not 400 but 200 to have it a bit smaller. And now again, NextJS automatically resizes the image to the size that we actually render here. Now to show you this, I have to zoom out a bit because I set up windows in a way that everything is 50% bigger than normal. But this causes NextJS to load these images at a bigger size than necessary, so I zoom out to the original size, refresh the page, and open the image in a new tab. And now it's just 200 times 200 pixels, or a bit bigger, 256, but that's fine. The important thing is that we are not loading an unnecessarily large image here, even though this image is coming from the exact same URL as the bigger image here, which we are loading at 575 pixels. Okay, so we can already navigate between our card here and our details page, and we see the cache data immediately. But I still want to style these Pokemon entries here in the Pokemon entry CSS module. So we add a bunch of different classes here. Again, the link to the whole code on GitHub is in the video description below if you just want to copy the CSS. Otherwise, I'm just going to type it out. Display flex for the alignment. Flex direction column to put everything below each other. Align item center, which centers everything horizontally. Justify content center, which centers everything vertically. You can't see a difference now, but later in the list this will make a difference. Then we set color to black so that the link is rendered in black as well. And I want to set a min width to 210 pixels, which means that this whole entry will not get a smaller width than 210 pixels, even if we make the window very small, because then everything would look squashed. But I don't even know if there are screens that are smaller than 210 pixels. Then we also add this card tag, which we added to this div here. Again, we set display flex, flex direction column, align item center. Then we want to set the background to RGBA, where we can set a color with transparency. We set this to 255, 255, 255, and then 0.2. The last value is the transparency. Then we set backdrop filter to blur, which is a function that we call here, and we pass 5px as the value. And I have a typo here. This should be RGBA. And then when we save this, we can actually see the background color. So this background color has this blur effect from this backdrop filter. For compatibility reasons, we also have to pass dash webkit dash and then the same name, backdrop filter. And also set this to blur, 5 pixels. I guess some browsers need this value here set instead of the normal backdrop filter. I don't know which browser exactly needs this value, I just know that we should add it. Then we want to set a border radius to make rounded edges on this card. We set this to 16 pixels. Then we add some padding of 0.5 rem. If you want to know about the difference between rem and pixels, you can read this up in Google. Don't want to explain this here, but I want to set the width of the card to 100 pixels, which makes it fill the available space, which later makes it look better when we render this inside a list. Right now it looks stupid, but this is not how we will render it. And I also want to add a box shadow, but I'm gonna copy paste the value here. Again, you can pause the video and type this out by hand. This just adds this nice looking box shadow. And I think these cards look really cool. One more thing, I also want to add a min height to the entry tag of 260 pixels. We do this so that later when we load these cards into the list, they won't start with the height of only the progress banner, which looks really weird because then it grows in size. So instead I reserve the space of 260 pixels, even if the image and the name and the data of the Pokemon hasn't loaded yet. Okay, so then let's save this and go back to the index.tsx file where we want to render the list of these Pokemon entries. Now we will add the number of the page we want to load as a query param to the URL. So there will be a question mark and then page equals 1, page equals 2 and so on. We don't have to do this, we can also just put the current page into a state with useState and then modify the state to navigate between different pages. But the cool thing about putting the page into the URL is that we can easily navigate back to the same page, and even if we refresh the page, we open the same page again. Whereas a normal state will be reset after we refresh the page, and we would always start back at page 1. So again, in the URL there will be a value like this, question mark, page equals 1, page equals 2 and so on. And to get this value out of the URL, we need the next router again. So we create a const router and assign it to a useRouter. UseRouter, by the way, is also a hook. This is why it starts with the word use. Okay, then below we create a const page where we want to read router.query. This is the same value where we got the Pokemon URL param out of, right? We also called router.query here. And this is where we also get the page query param out of. So .query.page. Again, we want to turn this into a string. And again, this could be undefined, in which case we want to use page number 1 as a fallback. And the reason why this is a string is because the URL param we get back here is also a string. And in order to turn this into a number, we wrap this into this parseInt function. So we pass this string into a number. And below we want to use SWR to fetch the data for this page, right? This time we are not fetching a single Pokemon, so we can't reuse our usePokemon hook here. Instead we call useSWR again, but we have to import this first. So import useSWR from SWR. Let's also import the Pokemon API file. So again import star as Pokemon API from /network/Pokemon-API. Then we want to call useSWR, and this time we want to take the page number as the key, so that the data of each page gets its own entry in the cache. And for the fetcher function, we want to call Pokemon API.getPokemonPage, which again gets the page number passed as an argument, and this is also the key, and the key is automatically passed to the fetcher function. But when we try to pass the number as a key, like this doesn't work. We can only pass a string like this, but we can wrap this into an array, and now it works. And out of this, we can now get the data and is loading. Again, we could put this whole line into a custom hook to make it reusable, but this hook will only be used in this one place, so we can just keep it directly in here. Now remember that I explained that this entry in the cache, so the data for this page number, is stored under this key. So the key for the page number 1 in the cache will just be the number 1. Now just using the page number as the key can of course cause clashes with other entries in the cache that also use a page number. So if two different kinds of data both have the cache key 1, then they will overwrite each other. To avoid this, we add a second value to this array here. You can add it before or after, doesn't really matter. And this will just be a string with the name of the function. So we are adding the string to the cache key. We don't need this string for anything. We don't need to pass it to the getPokemonPage function. This is just there so that we can distinguish the entry in the cache. So now the cache entry will say getPokemonPage1, getPokemonPage2, and so on. And those are tied to this getPokemonPage call. And if we load any other kind of paginated data, then they will have a different key. And there will not be any clashes. Again, in the SWR documentation, they don't use this string, they use the URL of the endpoint instead. But again, I like to put these URLs into these separate functions here, and instead use the function name as the key. So again, these two arguments are passed to this function, but this function only needs the page number. So what we can do is we can declare an arrow function explicitly. So we can call this function here with parentheses and just pass the page to it and ignore the string. Now this page value is coming from our variable up here directly. We could also get it from the argument of this function, because again, the whole key is passed as an argument to the fetcher function. So we could also write it like this: array key, page. The key would be the string here, the first value that we pass, and the page is the page number we actually need as the argument. But since we have the page already here, we can use it directly in here. But it's important that the page is part of the cache key, so it has to be part of this array. Otherwise there will be no way to distinguish between the different pages in our cache. Okay, so now we are loading the data for each page. And again, a Pokemon page is just an array of Pokemon names. The data that we get for a single Pokemon is not contained in these pages. Instead, for each name, we will go ahead and fetch the Pokemon using our usePokemon hook that we already have, which we put into the Pokemon entry, right here. So now for each item in the page, we can just render one of these Pokemon entries, pass the name to it, and the data fetching will be handled internally by SWR. So first of all, above the return statement, I want to check if is loading. This time I don't put this directly into the layout in here. Instead, we can also use an early return to not even get to this return block down here. Which of these is more appropriate depends on your layout. If you need styling from the outer div on your loading indicator, then you usually want to put it in here. But this time we don't need any styling, so instead we write it like this. If is loading, then we want to return a bootstrap spinner. Again, this is a loading spinner. And this time, just to have a bit variation in our styling, let's use the animation border instead of grow. And to center this on the screen, we use the class names dBlock and mAuto. Okay, and then in the second return block down here, we render the actual list of Pokemons. So we remove the Pokemon entry for Bulbasaur, and instead we want to render a bootstrap row. By using a bootstrap row, we can easily make our layout responsive. You will see this in a moment. Here we can set the number of columns we want to have for the different screen sizes. On very small screens, I want to have 1 column. On small screens, 2. LG is large screens, 3. And very large screens, 4 columns. And then we add a class name G4, which adds some gap between these different items. Okay. And in this row tag, we want to take each entry in our data, so the Pokemon page we get back, and turn each of them into a Pokemon entry. And this, of course, we do with the map function. So here we put a block of curly braces. And then we call data.results, which adds the save call operator because data can be undefined as long as this is still loading, but this is fine. In this case, we will just render an empty list. Well, actually, we will render the loading spinner because its loading will be true while the data is loading. And then we call data.results.map. Here we get each Pokemon entry. One Pokemon entry is one entry in the Pokemon page we get back. This is one entry. We want to take each entry and turn it into a UI element. So we wrap this into another pair of parentheses, so we can put this into a new line. And in here we want to put a Pokemon entry, of course. But we also wrap this into a bootstrap column, which works really nicely together with the row to render a responsive grid. Since we are rendering a list here, each element needs a key set to it, a unique key. This helps React.js to figure out which element belongs to which data so it can re-render more efficiently. This is explained in the React documentation. The key for this will be the Pokemon.name because this is unique to each element. Each entry in the list has their own name. And then in this column, we want to render a Pokemon entry where we have to pass the name, which is, again, Pokemon entry.name. And again, the Pokemon entry will take care of loading this Pokemon internally using our usePokemon hook. And all of this will be done very efficiently with SWR. Let's already give this a try. When we save this, this should load page 1, right? And there they are. And each of them have their own loading spinner while the usePokemon hook is loading. Again, normally this would be faster, but we added this artificial delay to see our progress indicators here. And now when we click any of these Pokemon here, we see the data immediately. Only the image needs a while to load because this is a different image, it's a larger size. But the data itself is there immediately because this is coming from the same cache entry. We can actually make this a bit more obvious by opening one of these Pokemon, Bulbasaur for example, and then I refresh the details page, which clears the cache and loads this data from scratch. So we see the loading spinner here. And now when I navigate back to the previous page, you will see that Bulbasaur will be the first entry that we can see on the list. Because again, this is coming from the cache, whereas all the other entries are removed from the cache and have to be loaded from scratch. So I navigate back and Bulbasaur is there immediately, because this is the cached value. But again, NextJS still goes ahead in the background and fetches Bulbasaur again, so if there is any new data to show, then it will update this entry a moment later. Okay, cool, so the pagination is already working. Now of course we need buttons to load the next and previous page. So I want to put them below our row here. And by the way, I also want to show you the responsiveness. So when I make this big, you can see that we now have this nice responsive grid that changes the number of columns depending on the screen size. This is the min width here, we can't make it any smaller. And this is also why I like Bootstrap, because it makes it very easy to create responsive layouts. Okay, now let's put the page loading buttons in here. So we create another div with some classes applied. dflex, justify content center, gap2 and empty4. Write out all of them. Then in the Pokemon page data we have this next and the previous string, which are null if there is no previous or next page to load. So we can use this information to show or hide the next and previous page buttons. So here we add another block of curly braces and check for data.previous, which uses the save call operator because this can be null. If this is not null, only then we want to render the previous page button. For this we import a bootstrap button. The text of this button will say previous page. It doesn't appear on the screen because we are on page 1. Let's try entering page 2 manually. And now we have the previous page button, which doesn't do anything yet. We want this to change the query param in the URL to the previous page, right? So we add an onClick handler here. and an arrow function. And here we can use the next router to change the query params from page 2 to page 1. We do this by calling router.push, which navigates us to a new URL. We call this and add curly braces in here, because now a cool thing we can do, instead of defining a whole URL where we want to navigate to, we can just change the query params with query colon, another pair of curly braces. Then we want to keep the other query params that we might be having in the URL. Right now there are no other query params than the page. But if there was, we wanted to keep them in the URL as well. So in here we spread the previous query params with ... router.query. This puts the already existing query params into this object here. Then comma, we only want to overwrite the page, right? We want to set this to a page -1. So we take the current page we are on and subtract 1 from it. If we are on page 2, we navigate to page 1, from page 3 to page 2 and so on. And this button will be hidden if there is no previous page, so we will not get a value 0 or something like that. And then we can duplicate this for the next page button, just that we check for data.next. The text will say next page, and we want to navigate to page +1. And again, if there is no next page, this button will be hidden. So as you might have noticed, we are not actually doing anything with the string we get back, which is the link for the previous and next page. We actually don't need this, because if we just pass the page number to our getPokemonPage function, then this will construct the correct link automatically. We just want to check if there is a previous and a next page to decide if we render these buttons. So let's save this and try it out. We are on page 2, let's try page 1 again. You can see the data for page 1 is there immediately because it's still in the cache. The same is now the case for page 2. But when we open page 3, we will see a loading spinner again, because this page isn't cached yet. But now it's in the cache. Now we can reach this page very quickly as well. And I already showed you that the detail page draws from the same cache. Really cool stuff. Now let's actually take a look into the SWR dev tools again to see the cache data. So we can see we have entries for each Pokemon, and we have an entry for page 3, which combines our two keys, the name of the function, the string we added earlier, getPokemonPage, and the number of the page. This is both part of the cache key. I don't know what this add is for. I assume this is there because this is an array, but it doesn't matter. When we click on previous page, we also get an entry for page 2 and all these separate cached Pokemon entries. Okay, so this is how pagination with SWR works. And the only topic left I want to cover in this tutorial is mutations. Mutation might sound scary, but this is actually just a way for us to modify the local cache, which is what we usually do after we updated some data on the server via a post request and we got a response back that contains the updated data. Then we can use this updated data to update the cache immediately without having to wait for another revalidation. Now we can't actually change any data on the PokeApi server because this is not our server and we can't make any post requests there to update something. But we will simulate this behavior. What I want to do is I want to add an input field to the Pokemon detail page where we can give a Pokemon a nickname. Then we pretend that we send this data to the server and get it back and then update the local cache. Of course, nothing on the server is actually updated, but the functionality will be the same, so you will understand how this works. So first we go into the Pokemon API file here and add another function. Export async function. This one will be called setNickname. It takes a Pokemon as input of type Pokemon. And the nickname we want to give this Pokemon, which will just be a string. Now again, normally here we would now do an API request, update the data and then get the updated data back. So the Pokemon data with the new nickname. Here we just simulate this. We just return an object that contains all the data of the Pokemon we passed. So we spread these values in here with these 3 dots. But we want to change the name to the nickname. So we get the same Pokemon that we pass to this function back, just with the nickname that we set to it. Then let's go into our usePokemon hook again. In order to update the cache of an entry in SWR, we have another value that we can get from the destructuring declaration of useSWR. So after data n is loading, we also have this mutate function. We want to use this function on the outside, so we add this to the return statement. Let's call it mutate Pokemon, and we pass mutate as the value. And now we can use this function here to update the cache for a Pokemon with our own data. So next, let's go to the Pokemon detail page. Here I want to add a form to the layout. We put this below our div here, a form that's coming from React Bootstrap. It's also rendered inside this block. Only if the Pokemon has a value, only then we want to show this input field. We set a class name on this to empty4 to have some margin at the top. And into this form we put Bootstrap input fields. So the syntax looks like this. Could look a bit complicated at first, but this is how you set up input fields with Bootstrap and React. I teach this in more detail in my paid NextJS course if you want to take a look. But here we just need one input field, so we don't have to write a lot of code. We add a control ID value here, which we set to a string, Pokemon nickname input. The control ID is just an accessibility feature that connects the label and the input field. The label is a little text that is shown above the input field, and with this control ID value we can click the label and it will automatically put the cursor into the input field. And I think this is also necessary for screen readers. Don't worry about this too much, just add the control ID. And we add a class name of mb-3 to add some margin bottom. In here we put a form.label, which again is coming from Bootstrap, which will say give this Pokemon a nickname. Then to render the actual input field inside the form group, we add the form control, which needs a name so that we can get the value out of there later, the value of the input. We set this to nickname, and we can also set a placeholder, which will be shown when the input field is empty, e.g. Ferdinand. This is just a suggestion for a nickname the user can type in. And this is how this looks. So this up here is the label, and because of the control ID, when I click this label, the focus is put in here, and e.g. Ferdinand is just a placeholder, which will disappear when we type something in. Then below the input field, still within the form, we add a Bootstrap button. We set the type of this button to submit, and the text to set nickname. So now this button is here, and the type is important because this submit type tells the browser that when we click this button, the form this button is placed in should be submitted. This is why we don't have to add an onClick listener here. This button is automatically connected to this form. Now we just have to define what we want to happen when we submit the form, right? For this we add another prop to the opening form tag, which is on submit, and to this we can pass a function. We enter handle submit nickname, just like this, as a function reference without the parentheses. And then we want to create this function above. And this will then be called when we click the submit button and it gets passed all the input, which in this case is the nickname field. So above the return statement, we put an async function with the same name. Async because we pretend that we are making an API request, right? We made this async as well. We don't actually do anything asynchronous in here, but in a real app, this would most likely be async because you want to make a request to a server. Okay, now we want to get the data out of this input field. And this onSubmit handler function in the form gets passed one argument by the form, which is often just called e or event. And this is of type form event. The input doesn't seem to work automatically. I want to import this from React And what I want to import is this form event type. And then we add angle brackets here and write HTML form element, because this is the input field in our form, and this way we can get the data out of this input field. In my paid NextJS course, we use a library called React Hook Form, which makes extracting the data out of larger forms with more input fields easier. But just for this one input field, this is a bit overkill, so we get the data out of here manually. And for this, we first have to call e.preventDefault. Because by default, when we click the submit button, the page of the browser will actually refresh, because this is how this is handled in normal JavaScript code. But in React, we usually want to avoid this. This is why we call e.preventDefault. And then we want to get the data out of this input field, which again is a bit complicated because we are not using a library here, but it only takes a few lines. So we create a const form data, initialize this as new form data, and here we pass e.target, which is coming from this form event. So this is referring to the input field, but because of TypeScript, we have to cast this with the S operator to HTML form element. And now we can get our input out of this form data. So we create a const nickname and assign it to form data.get, to which we have to pass as a string the key of the input we want to get out, which has to be the same as we use down here as the name for this form control, nickname in all lowercase. So out of there we get form data entry value. We want to turn this into a string by calling toString on it. Again, this can be undefined, but this is fine. It's undefined if we didn't enter anything. And then I also want to call .trim. Trim removes any white spaces from the start and the end of the string, because if we type in something like this, then there is no reason to keep these empty spaces here. Usually you want to get rid of them, and you can do this with this trim function. Okay, then we want to update the Pokemon data. But the Pokemon can be undefined and the nickname could also be undefined. So first we check if !Pokemon, so if it's undefined, or !nickname, then we just want to return. I think there's no reason to show an error message or anything. I think the user will understand that if they don't type anything in and clicks that nickname, nothing will happen. This is why we just return from this function. Okay, and then we want to pretend making our API request to update the data on the server, right? So we create a const update equals await Pokemon API. Again, we have to import this. Import star as Pokemon API. Oops, that's a typo. From /network/Pokemon-API. Then we use this here. Await Pokemon API dot set nickname. Now we know that both the Pokemon and the nickname are defined because we are below this if check here. So we pass the Pokemon and the nickname input. So now we pretend that we make a network request, update the Pokemon, and then get the updated Pokemon back. And we want to use this updated Pokemon data to mutate our local cache, to show the changes in the UI immediately, without having to wait for SWR to make another request to our server. So here we need our mutate function from the usePokemon hook, called mutate Pokemon. And then it's actually quite simple. We call mutate Pokemon and pass the update, because the update is the updated Pokemon. And this will update the local cache and we will see the changes in the UI. Now after we updated the local cache, SWR will still go ahead and fetch the latest data from the server. We can disable this again by adding some configuration here in curly braces. We can set revalidate to false. So after we updated the cache, we don't do another network request to the server, which for one is unnecessary. But in our case it's also a problem because remember, we don't actually change the data on the server, we just pretend we did. So we don't want to make another fetch request immediately, which would reset the name in the UI. So we set revalidate to false, but in the real app this is usually not necessary because another network request is not very expensive. So let's save this and try it out. So I'm gonna rename Kakuna to Ferdinand. Set nickname. It changes the name in the UI and also here in the title. But when I click on another window and then back on our page here, revalidation will kick in and reload the latest data after a second or so. And it's set back to Kakuna. But this is what we expect because again, we don't actually update anything on the server. And I just noticed that I have a typo here. This should be a mutate Pokemon. So I really hope you enjoyed this little introduction into SWR. Again, I have a more advanced NextJS course where we build a bigger project with many more features. We also use SWR there, but in a more advanced way. And we use mutations where we actually update data on our own server. So if you want to check out the course, go to codingandflow.com/nextjs. I will also put a link to this page in the video description below. And then I wish you a nice rest of the day. Happy coding. Take care.